So a little bit about my background. I was a consultant with Deloitte for a few years in there, actually for Deloitte LLP, so Deloitte proper, not the consulting wing. And I basically analyzed data for them. I built data, looked for fraud in financial statements. And when I introduce myself, I usually say, you know what, when I was a student, I didn't take one accounting class. And then I showed up day one at Deloitte with this Accounting for Dummies book. And then I go and say, they tell me, hey, what are you supposed to do? And they're like, yeah, you're now a fraud accountant. I said, wow, am I brutally unprepared and unqualified for this job? But at the end of the day, most of the job was just basic addition, basic subtraction, looking for patterns in data, which happened to be in an accounting context, not necessarily a hardcore accountant. Then I worked for Citigroup during the mortgage crisis. Then I moved out to University of Hawaii to get my PhD. Spent 5 years in Hawaii getting my PhD. Then I moved to Richmond 3 or 4 years ago. I guess 3 years ago now. I will never get used to the weather in Richmond. I mean, how do we go from 70 degrees to 30 degrees in a matter of 24 hours? The weather here is just schizophrenic. So when they came to me to give this talk, had a bunch of different titles for it. Big data is a topic that is, I guess, a hot topic right now in the sense that people are talking about it a lot. We go to a lot of these academic conferences and everybody's got an opinion on big data. And oftentimes when we're talking about big data, it's really, we're still trying to answer the question, what is it? What exactly is big data? And then once we figure out and kind of define what it is, how do we actually use it and implement it inside of an organization? So I'm just going to go through what I'm just titling here, a few random thoughts about big data and analytics. Before I get going, and then I will get going, I promise, a lot of the ideas that I've used in this presentation come from these two books. One's by Tom Davenport and colleagues, wonderful book about big data inside of organizations. And another book is just big data, some random thoughts about big data at the societal level, and they also have some firm level. So if I don't cite certain things, it's probably coming from one of these two sources, and please feel free to come take a look at those. Found this great quote from 1941 talking about the information explosion. And they were talking about the power of PCs don't have enough capacity to manage all of the data that we currently have inside of an organization. That has not changed. Okay, what are we, 75 years since 1941? Okay, we're talking about more zeros, but at the end of the day, we have similar problems. We're trying to gain insights and find some type of valuable information or some type of valuable, actionable insight that we can implement inside of a decision, and we've been battling this problem for forever. Okay, now again, our machines are more powerful, but the data is more prevalent as well. Big data is a buzzword. Okay, we're going to do big data in the cloud, and then we're going to implement some business intelligence systems, right? It's to the point where it really is just people are throwing it around for anything and everything that we're doing that a firm may or may not be doing with data. Okay, so one of the objectives I have for this morning is to just, let's see if we can't ground that and come up with at least some type of common understanding for the difference between data analysis and big data and what firms may or may not be doing with it. Okay. When we think about data, where's it all coming from these days? Well, PCs, okay, clearly that's been a growth area. And just by PCs, we just mean general, kind of the traditional Windows, the traditional desktop types of environments, and that's generating a ton of data for us. Then we've got our smartphones, then we've got our tablets, but the real growth in data in the next 10 years is going to come from these Internet of Things. These traditional devices that have been offline that are now becoming online, like a truck, okay? And we have all these sensors inside of a truck. That's a computer, okay? And that is a computer that is generating a ton of data that we can then use for something. our refrigerators, our appliances, the utilities inside of our homes. That is going to be a tremendous growth potential for the source of data. Then we've got our wearables, our TVs, and our connected cars as well. Data comes from user-generated content. I mean, we've got people go online and post all kinds of stuff on all different types of sites. And again, we need to try to gain some type of insight off of that. And again, if most of these people are probably in my class on Facebook doing what they need to do. Censored data. Again, we can really gain some wonderful insights into how employees are behaving, how employees are managing their time, if we can embed some type of sensor in either their smartphone and collect all of that location-based stuff. Now, you might be going and saying, well, that's unethical, we shouldn't be doing that. That's a different question. Okay, but in terms of a source of data, tremendous source of data for that. Everything's connected, everything's online, location data, tracking trucks, tracking cars, tracking Uber, tracking everything. It's all out there for us to go ahead and try to organize and analyze. Okay. Part of the reason I go through this, the first couple of slides there is it's easy to talk about the size and go and say, wow, that's big. It must be big data. And Davenport, when he introduces his book, he talks about and says, well, it's an unfortunate name. Okay? Because big data, the first thing we think about is big. Okay? And the first attribute, or we seem to think the most important attribute, is the amount of data. That's not really the essence of big data. The essence of big data is the unstructured nature of all of the data. 15, 20, 25 years ago, whenever we were talking about data files, we were talking about very specific rows and columns. Okay? We got to put it essentially in our spreadsheet on steroids, and then we analyze it that way. And that's and that's data. Okay? So now we then, somebody along the way went and said, well, now it's big. It can't fit in your traditional relational structures, so it's big. And then over time, that morphed as well. But again, size is only a very small part of the story. We really want to be talking, when we're talking about big data, about the size of the insights. It's big insights using data. And when we think about unstructured, so what do I mean by unstructured? All of your tweets, all of your Facebook liking activity, all of your Facebook posts, all of the hours of YouTube video. I can't put a YouTube video in rows and columns. It doesn't work. Okay? I can't analyze that type of data using our traditional tools and technologies. So big data really comes into this form of, hey, we've got a bunch of different layers of software. So maybe I've got one set of architecture analyzing all of my social data. And then I've got another architecture analyzing all of my video data. Then I've got another architecture analyzing all of my accounting and finance data. Then we get another layer on top of that that's trying to make sense out of all of it. Okay, we're not essentially trying to put it all in one spot. We recognize that there is not one store to handle all of this. So we just keep it wherever it is and then build software on top to try to integrate that in as fast of a processing time as possible. This was a wonderful quote. I don't remember exactly who said it, but when we think about your traditional finance data, that's pretty organized stuff, right? I mean, we've got pretty standard rows and columns. There's a standard format for your income statement, for your balance sheet, for your ERP systems. Okay, if we want to work with structured data, we'll go to Wall Street. Okay, and we'll do that, and they do it really, really well there. But that's not necessarily big data. Big data would be taking that structured data and then combining all of the tweet activity out there, mining the tweets and trying to come up with some type of sentiment analysis that you can layer on top of your traditional sales and sales forecasted information. Okay, the 4 V's, 5 V's, 6 V's of big data, essentially the volume, variety, and velocity of a firm's data. So once those 3 elements exceed a firm's capacity and ability to analyze the data, it becomes big data. So an example I like to talk about here is if I were to go to our admissions office and say, wow, here's 10,000 hours of YouTube video about possibly incoming freshmen or people that have potential students, let's just say. And I would go and say, go analyze that data and come up with 5 insights. We wouldn't even begin to know where to start because we don't have the technology to do that. That's monster data for us. You go to some people in Silicon Valley, and they go and say 10,000 hours. They go and say, come to me when you get a couple billion hours. That's a waste of my time. Okay, so it's a relative concept. Okay, it really depends on the firm and what the firm's capacity is to handle it. Okay, so that's kind of the big data plus analytics. So now let's talk about analytics here for a second. And we've been analyzing data, firms have been analyzing data for forever. Okay, that this has not changed and this is not going to change. But when we think about analytics, we can really think about 3 stages of analytics. The original analytics was analytics 1.0, or the original analytics. Historical, what happened? What was our income last year? What was our sales last year? What was the percentage growth year over year? Historical, what did we do? And we're just trying to describe what happened in the past. We were also really interested in the why question. Why did we only grow by 10% last year? Or why did our revenue decline by 5%? We love that why question. And we're trying to get at the root why question using historical data. Not terribly sophisticated. The biggest challenge with these types of projects is certainly not the math. We're calculating basic averages, basic percentage changes. The hardest part here is cleaning the data. Organizing the data, putting it in one spot, on one technology, in one data store, and then writing our queries and doing our analysis off of that. And so the time-consuming part was gathering up all the data. Tons of stories where firms initiate one of these types of projects, and it takes them 6, 7, 8, 9, 10 years before they come online. Because these types of technologies require all of the data in a very structured format. If the data is not in that structured format, it's ignored. It can't be used. So Analytics 1.0 are built off of very highly structured environments. Then the internet kind of comes along and really throws that on its head and says, well, we can't do that. Okay, again, I can't store a video, or I can't store an RSS feed in the same way that I'm going to store your balance sheet data. I can't do that. Okay, so now these projects really start to stall, and these types of analytical projects just are not quite as effective. And they're relatively low value add. These are not terribly, they're just low value add projects. What happened? Well, I know what happened. I go into my ERP system and I get a pretty good idea what happened. I don't need these types of custom projects. So then we move to what Davenport calls Analytics 2.0. This is when we start to integrate these more unstructured approaches, and these unstructured approaches to data storage. This is when we get the technologies like Hadoop and all of your big data platforms, your HANAs of the world, your Oracle Business Intelligences of the world. These platforms start coming to bear. So now we're not organizing our data in rows, we're organizing it in columns. And that just transposes everything, transposes our thinking, transposes the way we actually extract the data, and the way that we can analyze it. So now we no longer have to worry about trying to optimize the structure of a relational database. Quite frankly, we don't care. Okay, if my data is stored in an inefficient manner from a space management standpoint, who cares? Okay, the trend is towards cheap hardware. Okay, I can go out to Amazon Web Services and partition as much space as I need extremely affordably. Okay, and if I'm too scared or I'm too risk averse to go out to the cloud, I can set that up with just cheap hardware inside of my own environment. Okay, so we're now fundamentally moving away from this relational data storage to something different: columns, Hadoop, spatial, clusters, and then we analyze and we have our algorithms built on top of that. The problem we have in this environment is we've spent so much time thinking about how do we store it? What's the technology that's going to actually enable me to do that, that we've lost sight of what are the cool predictive models or predictive models that we can run off of this. So we spent so much time on the technical side that now we become math light. And they're not terribly mathematically complicated. We still end up doing the basic types of things. Let's project out 1 quarter based on historical data. Well, that's more or less what we were doing before. Okay, that wasn't terribly insightfully new. Okay, so big data with small math. Now, we're either here or we're in the process of getting here. This is the idea of big data meets big math. Okay, so let's move beyond, again, the basic averages, the basic sums, okay, the basic historical looking types of things, and let's see now if we can't really put some of these economic models or some of these more complex models into our data. And let's see if we can't do that continuously. Okay, so if I run an analysis I do a sentiment analysis based on all of the people that are following me on Facebook, and I look at all of their posts, you know what? 3 days later, that analysis is already outdated. Okay, I can't go and say, yeah, give me 6 months and I'll put that together. No, we need to be able to do that relatively fast. So we take the technologies from Analytics 2.0, and now we go ahead and say, okay, what better math or more complicated math can we put on top of this so we can make some wonderful predictions? And that's where we're at, or where we're attempting to go with a lot of these big data projects. We want to know what will happen in the future. Can I predict which employees are a flight risk and then better manage them so they don't leave? Can I make a prediction about who my customers are, how much they're willing to pay, what they might want to buy as they're walking through my store? We don't have the option to go ahead and, let me gather the data, 6 months later send out a mailer and say, oh, wow, here's a coupon for this product. Because everybody's moved on. We just don't work like that anymore. Okay, we need instant gratification. And so Analytics 3.0 is the attempt to do that. So another example would be, as I'm walking through the store, and I'm walking through the grocery store, and I pause in front of a bag of chips or my wonderful 6-pack of diet beverage here, and they go and now they're running all of these predictive models and say, okay, there's a 57% probability that people who stopped for 10 seconds or more in front of this section of the store are also likely to buy this. And then they immediately send me a note to my smartphone and say, oh, by the way, at the end of this aisle, there's also a special on chips. That is instant, okay? And it's continuous. That's where we're attempting to go with this type of, with Analytics 3.0. Now, I don't care. Well, I do care, but big data projects don't care about the why question, okay? So why do people who troll my Twitter account have a higher likelihood of giving me a 1 teaching rating? I don't care. I just care that there is a correlation. There is a relationship there. Whether there's some psychological theory to explain why, that's not my concern. Okay? So we're moving away from trying to answer this why question. And that's challenging for us as academics, or for me as an academic. When I've built my career, or I'm attempting to build my career around trying to answer why people do what they do. So why do you use Facebook the way you do? Why are certain firms more successful with their cloud computing endeavors than others? And that's the questions that I'm trying to answer. Well, now we go for a big data, and we go and say, well, who cares? Who cares why you guys are in this room? The fact that you are in the room, let's look for correlations, let's look for patterns, and let's move on. So whether you made a cost-benefit analysis and said, you know what, I think I'm going to be better off in my career if I can network with a few people because I'm here, God bless you. Okay? But for a big data standpoint, we just care that there are people in the seats. And that's a tough thing for us to grasp. Yes?
In terms of data, what would you call Pandora's music algorithm where it categorizes music, delivers it to people?
Yep, that'd be I would categorize that as Analytics 3.0 because they're doing it in real time, continuously, as tastes change, as their user base is changing, as all the downloads are changing, they're getting new pattern recognition all of the time. The Netflix algorithm, same thing. I would categorize that as Analytics 3.0. But again, we don't care about why, right? Do I care? You're interested in Bruce Springsteen and Brooks and Dunn, two completely different, but we don't care if that user base happens to have that correlation. Wonderful. Now we're going to spit out a recommendation that says, hey, people who have downloaded this Bruce Springsteen song have also downloaded this Brooks and Dunn song. Why? Who cares? Right? Again, that's just not our concern. Our concern is the correlation. Okay, just go through a couple of examples here. We can use these Analytics 3.0, or really some 2.0 types of things, to make the same decisions, but faster. Okay, so here, think about like the gaming industry. Okay, the gaming industry, Harrah's, your Caesar's Palace of the world, they analyze player data all the time. And then they would analyze that player data and send you a coupon in the mail and say, hey, next time you're at Harrah's, here's a free night stay depending on what it is, or here's a free buffet, or $10 off depending on what your playing level was. But that takes time. That did take a lot of time. Well, now they can do that in real time. So they can take that player data, and before you even leave the facility, they can make some type of assessment and say, wow, I know that somebody who lost $1,000 the first time they became rated with their card, once they leave the facility, there's a 1% probability that they're going to come back. I need to get to that consumer before they leave the facility. Once they leave the facility, I'm toast. Me sending them a flyer, I might as well be wasting the 48 cents, okay, because they're not coming back. Or there's a 99% probability that they're not coming back. So they're not doing anything different. They're just speeding up that cycle time, and they're able to do that analysis before you've left the facility. Same decisions, but cheaper. And here I threw in Citigroup. Citigroup's not really doing it. They don't have any new algorithms, or at least they didn't as of like 2014, but they moved all of their stuff over to a big data architecture. So now I believe their cost estimate before was about $40,000 per terabyte was what it basically cost them per year. Now it's down to $2,500. Okay, they're not doing anything fundamentally different in terms of how they're looking for Patriot Act violations. They're still running the same types of things. They're just saving themselves a ton of money in doing it. Then we have better decisions. Okay, and here I'd throw in LinkedIn, Facebook. I'd throw P&G in there. Not the same decisions. They're fundamentally getting new insights into, if we didn't do this, we would not have known this in the past. And then product and service innovation. And here, think about GE. They're trying to build a turbine platform. Okay, they're not a technology company, but they're trying to embed the data analysis in their products and service offerings. Think about the automotive industry, where now instead of going in and getting your car serviced every 3,000 miles, there's a whole bunch of sensors, and that sensor data gets uploaded to their cloud environment. Then they have a whole bunch of algorithms that run and say, hey, now your car needs service based on the performance of the vehicle, not based on some arbitrary 3,000-mile number. So a brand new product or service offering because of the data and the analytics that they have. I think what you'll notice here, minus a couple of these, LinkedIn's that's a Silicon Valley-based company. Zillow's not exactly a stalwart, but most of these companies, P&G, GE, Citi, Harris, these are not high-tech companies. These are your traditional companies that have been around forever. And these are the companies that are driving Analytics 3.0. Your Silicon Valley types of companies, they love to develop the cool stuff. And they love to develop, wow, we developed Hadoop, or we developed this platform. And the people or the firms that are developing the use cases, they're the older firms. They're the traditional firms that are now trying to reinvent themselves as data companies, even though they're not the ones who actually developed the base infrastructural types of technologies. Big data is great. Firms love big data, but there are challenges with big data, and very real challenges and societal level problems associated with having data about everything we do, and having everything that we do tracked. And I have a little example here if it'll play, so just bear with me here if this'll. Nope. Okay, kind of funny and kind of scary when we think about what a truly connected world might be. And I joke around with my colleagues in the business school. Whenever I go in for like my routine physical and I get blood work and they come and say, whatever, your cholesterol's through the roof, I go and say, yeah, whatever. 2 days later, I get an email from some fitness program here at Richmond that goes and says, hey, join our fitness club to help your cholesterol and your heart health. I go and say, yeah, that's a private test that I just had between me and my doctor. But I just kind of laugh about it. But it is kind of scary when we think about it. Everything that you do is going to trace and track with you forever. And even deleting it, you try to delete something from the cloud and all of those different replicated servers up there, man, to try to truly delete it is darn near impossible. Okay, so we kind of have to just have under the assumption that we're okay with this and that consumers by and large are okay with this. And they may not be, but implicitly they are by going to Facebook and doing what they're doing. They're either incredibly naive or they're implicitly going and saying, hey, we give up. Okay, we're on this site. We want, one of the costs associated with this site is this lack of privacy. And the ability to build profiles on here is really not incredibly difficult to do. Let's also be careful so I think in maybe the late 80s, early 90s, we started to question the kind of UPenn approach to management. This hyper-rational, economically rational, I only do things if the cost-benefit analysis shows that it's absolutely the right way to do it. And what ended up happening was we started developing these cold, heartless managers. And then over time, people started to question that and say, is that really what we want? Is that really the type of manager that we want running our companies? And that we want managing our people, managing the careers of our people? And people started to question that. And I think by and large, we're slowly trying to move away from that and say, yeah, there are people aspects to management that are incredibly important. Well, now we're starting to have those same questions now that these hyper data sensitive data scientists, engineering types of backgrounds are now moving up into management types of positions. And now we're starting to say, golly, I don't know, is that the right manager that we want? Hey, I'm not going to do anything unless you give me the data that supports it. I don't know. You know, I knock on my manager's door. Hey, you got 5 minutes? I don't know. Come back in 20 minutes after I crunch the numbers and see if it makes sense for me to devote 5 minutes of your time to talk to you. It seems laughable, right? I mean, no, we don't want that type of manager. Or I think by and large, for at least a lot of different things, we don't want that. And some companies, and I clearly don't want to pick on, probably arguably the greatest U.S. company or the greatest company in the world, but there are firms out there that have taken this possibly too far in terms of everything's data-driven. If you don't have the data to support something, just don't even come to my office. That is probably too far. We're cheap. We're too cheap to pay for anything. Okay, you want to ruin Facebook, or you want to ruin Gmail, go and say you now have to pay a penny or a fraction of a penny for every email, every post you send. We're going to run for the hills. And we're going to be like, nope, not doing that. Okay, so how do we pay these companies? We pay these companies with data. Okay, so if everybody's opting out and saying, no, you can't use my data, that's great for me if I'm the only one that does that. But Facebook or Google, they really don't have a business model if we remove that. And we remove their ability to analyze data, cluster users, look for patterns to profile, and then run some analyses on top of those profiles. They don't have a business model. Okay? So we kind of have to balance this. We're too cheap to pay for anything. Okay? I'm not giving you any money. So we have to be comfortable saying, yeah, do whatever the heck you want with my data. And hopefully they don't do anything unethical or illegal with that data. And if I, as an individual user of Gmail, as an individual user of Facebook, if I'm not okay with that, it's up to me to go and say, you know what? No, I'm not going to use Gmail. I'm not going to use Facebook. I'm not going to use Twitter. I saw this, and I believe I gleaned this insight from an NPR kind of documentary that I saw And they said, what's interesting about search is we're not a consumer of search. We are part of the product. And the product changes with every search that we enter in their site. Then they can store it, index it, do whatever they need to. We're part of the product. And because we're part of the product, my data is a part of the product. And by being a part of the product, I no longer have to pay for it, because everything that I do on that product is helping that product and helping that product morph and change. And then it's also helping a firm like Google or Microsoft monetize that product by selling the different profiles and their different analyses to advertisers or to firms that are willing to advertise on their sites. Another fact here that we just have to be comfortable with: our data is going to far outlive us. Okay, so once we go away, that data is not going away. And this is a relatively new phenomenon in the sense that in your traditional data warehouse, we would clean that up over time. We would go and say, you know what, the 90s are over. We're going to archive or delete the data from 1990 to 1995. It's now costing us more money to keep it. Well, now with data storage costs basically nominal, minimal, just throw it up there on the cloud for a service, I no longer have that issue. I don't want to delete any data. Okay, we might roll off credit card information, but like the main crux of your profile and all of your posting history, that's out there forever. And that's not going away. You can go to Google till you're blue in the face and say, delete my history, delete my history, delete my history. All they're doing is archiving it. Okay, it's not truly deleted, because it's impossible to delete something from that many different servers and not have at least one trace of it. Okay, so I can guarantee you our data is going to outlive each one of us. Pilfer these examples from this book here. Man, imagine getting this. Imagine getting that in the mail. But when we treat a customer as a data point and not as an actual human, yeah, we're going to make these mistakes. Firms are going to make this mistake. They didn't do any. They probably didn't do anything. They probably had that data element, daughter killed in car crash, somewhere out there tied to this record, and it was in a field, and they went, and when they were doing this mass production of these mailers, that popped in. Man, that's scary stuff to think about what damage that might do to that person when they get that letter in the mail, depending on how close or regardless of how close to the event it was. And then another example of Target analyzed shopping patterns and past shopping patterns of consumers, and they sent a letter to like a 16-year-old daughter of somebody, and they went and said, "Dear future mom," or something like that. And they sent that to a 16-year-old girl, and then the parents open up that email, that mailer, and they stormed into Target, and they say, "What is this mess? You're sending this to a 16-year-old young woman." Goes home, throws a fit inside of Target, goes home. Sure enough, the daughter was pregnant. And their algorithm, just based on purchasing patterns, based on what they were stopping for and how they were actually walking through the store, Target was able to predict that that woman was pregnant. And then obviously, not obviously, but then the parents come back and say, "Yep, sorry, there were certain things we did not, that I was unaware of when I came in and yelled at you." But again, it can be pretty scary stuff. Okay, and then just this, a couple days ago, the Panama Papers. I mean, that's you can go online and look at all of these different accounts and who's tied with whom. It's just a wonderful site. Wonderful for us, not so wonderful for the Prime Minister of Iceland, who just happened to quit. And now all of this data, you can't put the cat back in the bag. Like, it's not possible. Okay, we now know histories of financial transactions with all of these leaders. And it's all out there in the public space for anybody to see. It can be fairly scary stuff. Okay. A couple more slides here, and then I'll either open it up for Q&A or we'll call it a morning. There we go. Naturally, I'm missing a slide here. But one thing we have that's interesting is University of Richmond is a liberal arts school. And that's our heritage, that's where we were founded, and that's kind of, we believe in a liberal arts education. Well, that's tough to reconcile when we have and when we're trying to prep a data scientist. Okay, I can't exactly hire somebody who majored in Shakespeare to become a data scientist and expect them to be up and running immediately. I can't do that. Okay, over in the business school, we've got a general business education that's not entirely specialized. It's somewhat specialized, but it's not like we can go and say, you need to take these 10 classes to become a data scientist. No, we've got a general liberal arts education with a general, embedded in a general business education. Yet I can't train a data scientist to do analytics 3.0 work with one little elective. Okay, in order to do this, I need 5, 6, 7 classes to maybe get them up to speed and ready to go on day one. But we can't do that, or can't's not the right word. We have a challenge to do that in an environment where you have to take 20 liberal arts classes. You have to take 5, 6, 7 gen business classes. You're only left with 3 or 4 classes. And we don't necessarily want to box in a 20-year-old and say, look, you've got to take these 6 or 7 classes, and if you don't, you can't become a data scientist or you don't have that specialization. So we're really trying to balance and say, what's enough so our students can be somewhat competitive with a job that will train them, but also maintain our tradition and our background as a liberal arts institution. So we're certainly battling that in the business school on a daily basis, trying to figure that out. Okay, I won't go through all of this, but let's just talk about this last point here. The big data revolution is about the speed, breadth, depth of the insights, and not necessarily about the volume of data. So when an employee comes to you, or you as a manager go and say, wow, we got a lot of data. We're doing big data. And we're doing big data analysis. Well, maybe not. Okay, let's just go and say, look, there's the data component, and our data management, and then what we're doing with it and how fast we're doing it, and then those types of architectures. Okay, that's all that I have. So if anybody has any questions, comments, concerns, thoughts to this.
So big data 2.0 comment, you talked about a couple of technology companies that were part of that play, Oracle.
Yep.
In today's world, somewhat mature organizations, expensive organizations, as you look at that 3.0 model, are there key technology partners that companies that you analyze that take that data out of food and all those other places and turn it into this framework that is done by basically Google search?
I would say these companies, these GEs of the world, I believe they're doing that using Hadoop and using HANA and using the SAP types of models, using MapReduce. They're doing that. Are there smaller companies that are also doing that? Some of your, the gaming platform, Zynga, they're doing that as well. So yeah, there are examples all over the place. And I hesitate a little bit to kind of box this into 1.0, 2.0, 3.0. The reality is those firms are doing all of that, or at least some combination of all of that. It's not like they've forgotten to do their historical reporting. Those are certainly inputs into all of the other things that they're doing. So I think there are lots of examples that we can come up with.
Do you find that there's a bigger trend towards open source software as opposed to the traditional purchasing a license for the company and support?
Yes, I think there's still people are still scared of the cloud, okay, in terms of The cloud is less secure than inside of my firewall. So take that aside, the idea of Hadoop, MapReduce, all of those types of software, that seems to be dominating. Okay, so I think the HANAs of the world that are a pay platform and you pay a premium for that platform are going to be in a challenging position. Okay, especially considering with a big data project, we don't know what insights we're going to come up with ahead of time. What's going to happen when we analyze this data? Well, we might, nothing. And that's hard to go and say, well, let's invest $10 million in this platform and knowing that we may get zero insights out of it. So that's why open source makes a lot of sense there. But open source, if you're then connected with the cloud, that's when it becomes powerful in terms of it's very affordable. If you now have open source, but then you still have to invest in your own infrastructure, you lose some of that cost savings, a little. I mean, I do think over time, people will come to realize and say, you know what, Amazon can secure my data up at Amazon Web Services just as good as the 6 people downstairs in Jepson can in this building. I mean.
You're talking about the daughter children car crash. Like, I kind of hear like one of the big things is physical stuff, type A, type B error. You know, that type of like, this one gets sent out really, really bad, so we need to weight it a certain way. Is that like a common part of these models? You know?
For the types of mailers that I have not seen anything that kind of that will effectively catch that, because they're processing 35 million of those a day. Doesn't mean there can't be, but most of those are still your basic, take this field, put it here, print out the label, and send it. So could there be something on top that goes and says, let's make sure and do a quick little quality check of all of these and go and say, if you see whatever, these 1,500 keywords, maybe go and say, you know what, let's at least pause and maybe put those into a bin that we actually have maybe a human or another set of software on top of that go and look at. But I personally have not seen any company where they're like, yeah, we actively do that. They kind of either grab and automatically build them or they don't. Do you mean a user being me as the consumer or a user as in the firm?
Both sides.
Okay.
So we have a whole bunch of robotic processors that knows how to interpret the data based on the input that we set for a preset into the software. That has to be preset first, the criteria that into the software. But does not help a major decision in terms of how you ensure the quality of the product.
I think a couple of things there. One, machine learning. Okay, so the old approach, kind of the 1.0 approach, was you have an operator, and that operator is manually updating and refreshing that system based on that team's analysis. Well, now we're seeing machine learning and going and saying, wow, the machine made a mistake here, and now the machine can self-correct, and the algorithms and the software in that machine can self-correct. Doesn't mean every self-correction is in the correct correction, but there is machine learning out there that is embedded in most of this stuff. Okay?
That's useful, like a very useful concept. That's where this whole industry is going.
Yep.
Watson's, like
Yep.
recently the
Yep.
Google chessmen.
Yep.
I mean, I think
Yep.
that's the
Yep.
artificial intelligence where it's going.
Yes, but again, there's still no guarantee, right? I mean, at the end of the day, if a hacker gets in and manipulates the data and then manipulates the algorithm, there is no guarantee. And I don't think there ever will be a guarantee, but I think the best they have going right now are these self-correcting algorithms that essentially learn and mimic the processes of humans.
But that's what Wall Street,
Yep.
Wall Street has a problem of manipulating those data. And that's where I'm going with
Yep.
this.
If it's systematic manipulation of the data, the algorithm can systematically correct for that. Where the algorithm's always going to struggle is there's these one-off cases where these people are manipulating. We as humans probably aren't going to catch that, and we typically don't. And then the machine's probably not going to be any better than we are as humans. But yeah, point well taken. There is absolutely no guarantee. And I would say that's another risk associated with just leveraging the software and leveraging the analyses as the truth without doing anything on our own. I agree. I don't know what else yeah, it is certainly, but I would also say we're still in the early phases of this. I mean, when we really think about big data, it really hit the marketplace, at least the term and the latest technology is 2007, 2008. So we're not even a decade old into this. And we're just firms are just developing those use cases now. So I think as we get errors and they make big mistakes, hopefully other firms can learn and say, okay, let's see how we can tweak the system. So my guess is 10, 15 years out, hopefully we see fewer of those types of errors.
What about governments? There's been a lot of news lately about making sure that the city of Richmond puts all financial transactions online so that taxpayers can see where the money's going. And the city officials have been trying to slow that roll.
Yep. I think part of that came with Obama, and his 2008 initiative to put, I don't think he necessarily lived up to this, but his idea of, hey, let's put everything out there online. I think as data become more embedded in society, like we have an expectation. So if I, as a Facebook consumer, have an expectation that I can see my profile that Facebook is using, if I become comfortable with that, I think over time, governments and elected officials will see a similar need. Maybe they can aggregate up that maybe one level so you can't get down to maybe the individual transaction level. But I don't have a great answer in terms of, I think we're going there, whether we like it or not. They can push, I think city governments and county governments can push back. At some point, though, I don't know is they're going to be able to do that indefinitely. I think we want to be in a transparent world where anything that's not classified is out there for all of us to see. So I think it's going to happen, whether it happens tomorrow or 5, 6, 10 years from now, I think it's going to happen. That's just an opinion. I don't necessarily know anything. Okay. Great. Thank you very much for listening this morning. Appreciate it.